Okay, so for the following circuit here, we need to find the following: I1 at 0, Vt, V1t, V2t, It, and I2t. So we have to find the equations that will represent these. We're given the equation for It though, so we're told that It is equal to that, and we're told that if I2 is 0, then it's going to be minus 1 milliamps. Okay, so let's start by finding I1 0. So this 0 pretty much means at this instant. Okay, so we know the equation that will represent this I. It's 4 times 2 minus e minus 10 to the power times 10. Sorry, 4 times 2 minus e to the power of minus 10t. Okay, let's rewrite this to be 8 minus 4e minus 10t. Okay, I don't like the bracket, so that's what we're going to work with. Okay, so let's see what we have to find. So we're also given what I2 will be equal to at 0, or this instant. I2 will be equal to minus 1 milliamps. So let's also find what I will be equal to at this instant by replacing t with 0. So it will be e times 10 to the power of 0, which will be 1. So it will be minus 4 times 1, which is still minus 4. So 8 times minus 4, that's just 4. Okay? So I at 0 is 4. And let's do a node analysis. So we see I enters the node, and I1 and I2 leave the node. So it'll be 4 equals I1 minus 1. So I1 at 0 is equal to 5 milliamps. So that's our first bit done. So we'll put that here. I1 of 0 is equal to 5 milliamps. Alright, let me erase all of this now. Okay, and now let's do the second part. We need to find Vt, the volt. So we have to find a formula for Vt, okay, or the formula just for V. So to find the formula, so we're working with inductors here. So what we can do is do the following: set out the formula to find the voltage at an inductor. So it'll be L times dt di over dt. So what will this L value be? Because we just have a voltage between two terminals. Well, if we it'll be actually the inductance equivalent, because that's what that pretty much how we can find the voltage at this region. That's pretty much like sorry, not the voltage, the inductance at this region. That will be the inductance uh, equivalent. So that's what L is going to be. Leq will be equal to the inductance equivalent. So these two are in parallel. So it'll be 1 over 4 plus 1 over 12 to the power of minus 1. So that's 3 henries. And 3 henries plus 2 henries, that's 5 henries. So it'll be 5 times di over dt. Now, the I value will be the one that's nearest to this V value, and that's this value here. So we'll replace I with this. So let me rewrite that. Much better. So it'll be 8 minus 4e minus 10t. Okay, so differentiating it, we find the derivative of this. It will be 0 minus 4e minus 10t times minus 10. Okay, so minus 10 times minus 4, that's 40 e minus 10t. Now 5 times 40, that's 200 e minus 10t. Okay, so that's what the formula for Vt will be. All right, now let's find V1t, the formula for V1t, it'll be equal to the inductance at that region times the voltage, times the current passing through it all over time. So it will be L is 2 henries, and the current passing through it is I, and I is represented by this equation. So it'll be 8 minus 4 e minus 10 to the power of t, and obviously that value was 40 e minus 10 to the power of t. Alright, so that means V1t is equal to 80 e minus 10 to the power of t. So V1t is equal to 80 e minus 10 to the power of t. Oh, and these are both in milliamps, so be careful of that. Now, V2 is actually finding the equation for V2 is actually going to be the easiest. So we'll do a mesh here. So this mesh will be the sum of all the voltages, okay? And they all have to equal to 0. So we enter this negative V here. Then we enter this positive V1. Now, this V2 is pretty much saying the difference of voltage between here and here, okay? So we'll just do plus V2 here, as the voltage between here and here is also technically V2, as well as the voltage from here to here, okay? So we enter through here, so it'll be plus V2, alright? And now solving, and this is all equal to 0. So solving for V2, it will be V minus V1. So V2t will be equal to Vt minus V1t. Now V was 200 e minus 10t minus 80 e minus 10t, and that gives me 120 e minus 10t, and that's the value for V2t. Alright, now we have to find the values for our i's. Now this is the scary part, okay? So just bear with me. To find the current passing through an inductor, so like this one, like I1 here. So to find the current passing through an inductor, it's going to be equal to 1 over the inductor times the integral from 0 to t times the voltage dt, okay, plus the initial current at 0, okay? And some equations just put it as t here, okay? But this is pretty much the equation. So I1t, oh yeah, and they usually just call it IOT, okay? But pretty much this is the equation. So let's start. So IL, so L is 4. The integral from 0 to t. Now, the voltage here will be V2, okay? So because to find the voltage of a inductor, it's pretty much the difference of voltage from here to here. So it's going to be V2 here. So it'll be 120 e minus 10t plus IO. IO will have that to be I1 at t equals 0. So it's at the very start. So like pretty much what I1 was at the very start. Okay. And we actually recall, we figured out what I1 was at the very start. It was 5 milliamps. So we can replace that with 5 milliamps. Alright. Oh yeah, and then put the dt here. Now we just have to find the integral for this. So the integral for this is pretty easy when we solve it separately here. So we can take out the 120 because it's a constant. So we'll have the integral of e minus 10t dt. So to find the integral, we just divide it by the derivative of up here. Okay? And then take the value from 0 to t. So this one will be e minus 10t all over minus 10 minus e minus 10, 0, all over minus 10, okay? So we put the first value here, and then we put the second value in here, all right? So it'll be e minus 10t all over minus 10 minus e to minus 10 to the power times 0. So it'll be just 1 all over minus 10, and so it'll be just be plus 10 plus 1 over 10 here times 120, because recall that was there here. So 120 divided by minus 10, that's minus 12 e minus 10t plus 12. So we can pretty much replace this whole thing into this region. So we now have I1 of t equals 1 over 4 minus 12 e minus 10t plus 12 plus 5. Now, distributing the 4 in, so minus 12 over 4, that's just minus 3e minus 10t plus 3 plus 5, 5 plus 3, 8, 8 minus 3 e minus 10t. That's your formula. All right, so now that's I1t done. All right, now we just have one more part to solve. So now they want the formula for I2t. Let's do a node analysis. So I is equal to I1 plus I2. IT was IT was this. So it's 8 minus 4e minus 10t, and that is equal to I1, which is 8 minus 3e minus 10t plus I2t. Okay, so let's bring this to the other side. This 8 and the 8. So sorry, let's actually just write it down first. Minus 8 plus 3e minus 10t is equal to I2t. So 8 minus 8 cancels each other out. Minus 4 plus 3, that's just minus 1. So minus e minus 10t is equal to I2t. And that's your final answer.